So today I want to show you a little bit, or a demo that actually demonstrates or illustrates some of the intermolecular forces that we've been talking about. So viscosity was one of those intermolecular forces that we thought was, that we think is associated with how strongly attracted molecules are in a sample of any given substance. So what I have written up on the board here are 3 samples. We've got some methanol, some ethylene glycol, and some glycerin. And what you'll notice about those, if you've looked over the intermolecular forces information in those lecture videos, is we have hydrogen bonding present in all 3 of these molecules. But what I hope you also notice as I've drawn these out, drawn their sort of condensed structures out, is the methanol just has 1 hydroxide group or OH group and 1 area of hydrogen bonding. The ethylene glycol has 2 hydrogen bonding groups on it, and the glycerin has 3 hydrogen bonding groups. So we would predict, looking at that information, that the glycerin would have the strongest intermolecular attractions to other molecules of the same type. We would call this the medium strength out of the 3 of them, and we would say that the methanol probably has the weakest intermolecular attractions between molecules out of these 3 samples. Now, what does that mean for the viscosity? It means that those molecules, as they're tumbling over one another in the liquid, will move more freely or tumble more freely if they have lower intermolecular attractions or weaker intermolecular attractions like the methanol. So let's see if that's actually true. Joe has brought us these 3 burettes filled with the different substances. We've got the methanol here, the ethylene glycol, and the glycerin. He's added some food coloring to those so that you can actually see them. But we're going to start draining these burettes, and we're going to see which ones empty the fastest. And that will be a demonstration of how freely those molecules flow or tumble over one another and how weak or strong their intermolecular attractions are. So now all 3 of those burettes are open. And what you hopefully can see is that the methanol, even if you can't necessarily see the stream coming out, you can see that the liquid level up here is draining pretty rapidly. The ethylene glycol next to it is coming out at a pretty good pace, but it's not draining nearly as quickly as the methanol. And then if you look over at the glycerin, you can see that just a drop or 2 is coming out every few seconds. So the drops are forming very, very slowly here, and it would take hours for this burette to empty of that glycerin. So we'll let that go just for a minute so you can see that contrast. And I always trust that Joe filled them up with just the right amount of liquid so that when it all runs out, the bottles catching the liquid won't overflow. So this is just a direct link, something that we can see, a macroscopic scale event that links back to those microscopic molecular properties that we're learning about. So clearly the methanol has much weaker intermolecular attractions than the other 2 substances, and the glycerin having the strongest, therefore being kind of sticky and gooey and not flowing very well. So that's a demonstration of viscosity.